That takes us to milling. Some very, very interesting items taking place in milling. And remember, these aren't exclusive just to milling. If you've got a mill turn license, you'll find that you've got these commands inside a mill turn license as well. So this first item, you may be forgiven for thinking that you're looking at a drill cycle, because inside a drill cycle you have an optimized path function. Well, the optimized path function has now been rolled out and included inside our roughing cycle and inside our profiling cycle. And I guess you'll know and appreciate why that is, because we want to specifically order the manner in which items are actually machined. We don't want a tool hopping around from the top left-hand corner to the bottom right-hand corner, wasting time as it traverses across what could be a 6-foot work plane. We want it to go to the nearest neighbour. So that's now included inside both the roughing and the profiling cycle. A brand new cycle, maybe a little bit specialist, an engraving cycle. This isn't to be confused with the text machining cycle that we've had for many years inside Edgecam. You can create text, true type font text inside Edgecam, or just standard font, and machine it using the text machining command, or you can use a roughing cycle or a profiling cycle. This is a brand new cycle, very, very specific, where a customer might have a certain font or a certain type of artwork to machine in, and I'll be showing you this very shortly as we move through to a live demonstration. We now support inside the milling environment the ability to power rotate the table. So that's to say, if I was machining a part, normally I'd see that part being performed in XY in planar. That can now be done in rotary, and obviously that gives us a greater scope in respect to not over travelling on a machine axis. And this is probably the most important, the most interesting one, I feel. Certainly in terms of saving time, this produces great benefits to us. This is all about lessening the amount of work you have to do in respect to preparing a file for manufacture. So before you create a CAM instruction, whether it be profiling, whether it be flatland, etc., you'll appreciate, I have to do boundaries, I might have to do face features, etc., etc. Well, this is now taken away. That preparation now is becoming more and more minimal as we move through versions in Edgecam. So what we'll now find that we can directly select solid faces off a solid part file, and Edgecam will protect the rest of the unselected faces. Does that with a silhouette boundary. For all the other CAM instructions, for all other 3D cycles, you can now use a face for the boundary. So you don't have to keep creating edge loop features as boundaries. That's now performed by a face feature. If you want to use a boundary, by all means do so, but it's much quicker now to use a face feature. Okay, so let's take a look at those items. Just open up an item here. Let's just move back onto number 3, and we'll start with maybe one of the more simpler ones. As we look at this particular item, this item is to do with, as I said before, milling, and it's to do with the movement as we machine around the part. So what we see here in plain Edgecam is just a profiling cycle. As we move that inside to the machine simulator, you may guess what's going to happen is that we're going to go over axis, we're going to cause over travel. I think I'll just turn that on here just to accentuate the problem. So stop at axis over travel, and we'll play through. So obviously we get an XY movement of that machine tool table. So the cutter's beginning to machine, but straight away you'll notice that we've stopped because of over travel. I just try and play it on a little bit. Obviously Edgecam's detecting the fact that from the code wizard, from the post processor, it's incapable of going that far. And so this would have been stop you in your tracks, and you'd have to think of an alternative method. What we have now inside milling, and maybe some of the turners would appreciate this and recognize this, is the ability to select the mill mode onto rotary. So where possible, Edgecam will now rotate the table in order to position the profiling cycle. So if I go back into machine simulation, see how the table turned, and now we're machining using the rotary axis. So do remember that this again is obviously part of 2015 R1, but make sure that your code wizard, your post processor, gets upgraded into 2015 R1 to take on the new functionality and the new code constructors and tokens that support this particular enhancement. That's all it is, just the ability to swap between planar machining and rotary machining. The other item that we also spoke here, a little bit specialist, is the engraving cycle. Let's just dismiss this. Okay, so we've got 3 engraving cycles here. As you can probably tell, the cycle will work in 3D and also 2.5D, and the cycle also works in wireframe on solid features and directly onto surfaces or solids as well. Let's just look at the E and the C, just try to simplify this, but normally we'd see customers presenting with quite complex artwork or something that's been molded. And all we want to do is drive the tool centrally down the letter E and down the letter C, more like a roughing cycle or a slotting cycle. So if I look at the first engraving cycle, that's what we're doing. We're picking the solid feature, it's been feature found, and I'm going down the center line. So I don't want the tool trying to generate and doing step over and taking a lot of time in respect to machining this part. I just simply want it to find the dead center and take out the bulk of material. The other item that we'll see in engraving is the finish, and this is very, very specialist. We tend to find that engravers will use a taper tool, and when the tool reaches a corner, internal or external corner, the tool ascends to the top and then descends, feeds down to the base, and it's actually forming the corner for us. Let's take that into the machine simulator. It's probably better off seen inside the machine simulator, and for purposes of this I'm just going to turn off the machine itself. So the first one is the slotting command. All I've simply done is ask the tool to select a center line. And so you'll see now it's just, if you will, roughing out that area for me in readiness for the finishing command to come. So I just digitize the feature. It doesn't matter how complex that feature is, it will always find the center line for us. When we come to the next engraving cycle, this is a finishing cycle, and this is very, very specialist to people who wish to do this type of work, wish to do engraving. What you'll notice is that the tool, as it gets into a corner, will rise and fall. Just maybe see that now, rises and falls. And that's just making sure that the corner is razor sharp. Rises and falls. So it comes to that letter C corner, and it's just formed it with the taper side of the tool. So again, that's something that is brand new inside 2015 R1 and could be found in both mill turn and turning environment, milling environments. Let's look at the pocket ordering. Again, this will represent quite a substantial amount of time saving, especially on very large parts. You know, this part I've set up on a planar miller. This might be a 10-foot wing spar where I'm wishing to machine these individual features. We've been able to achieve this in the past in Edgecam, but what we've had to do is manually select each feature, which, you know, if you've got 10 plus features looking at you, it can obviously take a lot of time. This is what we see. This would be the typical net result as the tool dances around the part. That can obviously be wasting a lot of time. What I want to do is it to go to the nearest neighbour. That's a terminology that we've heard inside drilling, nearest next. So that's what we're adopting inside profiling and roughing cycle. We just edit this cycle. You'll see now inside control you have optimized path. If I say go X lace in the X direction and staying within 80 millimeters. Now if I replay that command, so now you'll see it's now adhering to an X direction. It's not jumping around the part, and it's finding in the Y direction the next nearest neighbour. So it's a much more economical tool path, and on very large parts that will represent quite a substantial time saving. That's in the roughing, and it's in the profiling cycle as we see here, and an optimize path command. Okay, so I'll save the best to last. This is picking faces, and I think this one's going to represent quite a very, very big significant time saving to all users. What we see here, and again I'll just hide away some of the toolpaths so things are a little bit clearer for us on the screen. So first of all, I want to concentrate on the parallel lay cycle and on the constant cusp cycle. I'll leave my cursor on the constant cusp finishing cycle. You may notice that the actual tool is gouging into the part, which is not very good. So we know that when we machine in Edgecam, we pick faces or we pick the whole of the solid body, but by inference that means it's going to machine all the solid body or all the face, so we tend to use containment boundaries, and that means us having to prepare things. So here inside my feature area on my top left hand side, I've done a boundary for the parallel lay cycle to clip that inside, and I've obviously used the face feature to select the face. Well, these are now not necessary, and to prove that I'm going to delete them. And remember that by deleting them it will obviously put my 2 cycles in jeopardy, but I don't care, I don't need them anymore, and that's the whole point of having this direct picking command. So we look at the parallel lay cycle, that's the cycle on the left hand side. There's a new option, pick the solid face, and that's exactly what we'll do. We'll go directly to the face that I wish to machine. I'm not having to pre-prepare it or anything. It's straight to the solid body, select the face, and then let the cycle take effect. Now what you'll notice is indeed it has machined the command, so it's gone straight to the face, machined the command, which obviously inference means it's going to be associative, and also it's protected the sidewall. I've not had to use a boundary to pull it away from the remaining neighbour of the solid body. So it's actually using an internal, if you will, silhouette or an internal boundary to pull that toolpath away. If we look at the constant cusp finishing cycle, again you'll see that plenty of gouging going on there. This was originally created by creating a face feature, so I've actually gone into a feature finder scenario and done a face feature, and obviously that means more work for me, so I don't really want to do that work, so I'm as lazy as the next person. So I've removed that face feature. That's why the constant cusp cycles are currently in jeopardy, so it's good to see the red coming on and warning us. What I'm going to do is I'm going to edit that constant cusp cycle, and again notice that we have pick solid faces. So the inference is I can go straight to the solid face and select and finish. I don't need a containment boundary. It will just automatically create my constant cusp finishing cycle, and again see how it's pulling the toolpath away, so it's protecting the rest of the solid body. So more intelligent machining and a lot less preparation in getting that cycle ready to manufacture. I'm just going to make these 2 other first cycles disappear, and I'm just going to turn on the profiling cycle, because some of you may appreciate that the profiling cycle in 2014 R2 already had a pick faces command. Just like to do some extra demonstration here. So in this case my profiling cycle is digitize the whole of the solid body, and clearly that's what it's done. It's machined all the solid body, including, you may notice, the chuck jaws, and I obviously want to correct that. So if I edit my profiling cycle, what I simply want to do in the first instance is pick the solid faces, and all I wanted to do is really just machine that central boss on that particular part. And that's exactly what it's done. So again, that's another very good example of not having to create boundaries, and obviously let the intelligence of the cycle decide which area it can reach, which area it can get to. So I've not had to create boundaries. But what you may notice, it's also gone and hit the vice jaw. Obviously not a very desirable condition. So what we'll now notice is that the profiling cycle is now enjoying what the roughing cycle has been doing for a number of versions, a use check fixture. So any recognized fixtures, whether it be solid bodies that you brought in yourself and declared them as fixtures, or in this case the fixtures have come from the fixture manager, but that will now correct my toolpath, pulling the toolpath away from the danger zone. So again, it's an extremely powerful command. So what we'll find is that 4 of the cycles have now taken on board that particular command. the ability to directly pick faces, and as time moves on we'll notice and observe that many other of the 3D cycles will begin to take on direct picking faces. But there is something extra that I'd like to show to you. This is where a face can perform the job of a boundary. So this is a project circular pattern command, very common command. This is one of the 3D cycles that at the moment hasn't got direct picking of faces, but it does have, like all 3D cycles, the ability to have a boundary. Let me just show you what I mean. I just clear the previous pics. So first question is the surface of the machine, so everything. Because it's a circular pattern command, it's asking for the outer arc. And then when it comes to the containment boundary, this would have normally been an edge loop feature, and you'd have to pick all the edges that were positioned around the part. Now what you may do is just go straight to a face or faces, and it will now make the face as the boundary. So it's a lot quicker than having to chain your way around edges and off loops off a solid body. It's a lot quicker now to work with the faces. So again, I'd recommend those enhancements to you in 2015 R1.